All right. Hey guys, Mr. Kyle, Myers Mathematics, and just wanted to jump into something real quick. Today's a little different. My face is a lot bigger instead of into the top right corner if you're familiar with some of my other videos. And just wanted to maybe take another little break from a very long Algebra 1 worksheet series that I've taken a while to do to give a couple thoughts on just number theory, but not in a mathematical sense. Just the theory of like the number 3. So 3 is one of my favorite numbers. It's not my favorite number, but it's one of my favorite numbers because it comes up so much in so many different areas. Like if you just look at like the fundamentals of the universe, right? So like we live and interact in 3D. It's possible, there's more dimensions of space out there, and there's a lot of different theories on that and stuff, like 4D, 5D, 6D space, whatever. But we live and we interact with 3D space as we know it, and so three dimensions of length, width, and height. So there's your first three. Or how about states of matter, right? So if you know a lot about states of matter, then you probably would be like, oh well, there's like four, or maybe you say there's five. As far as I know, there's potentially like five, but really the three that matter the most that we normally interact with are going to be your standard ones that you hear about in school. And in high school, if you're somebody in high school watching this, you probably know it's solid, liquid, and gas. Right? So three states of matter: solid, liquid, and gas. So if you're wondering, if you don't know what the other two potentially are, it's called I believe one is called Einstein-Rosen condensate. Let me know in the comments if I was off a little bit on that one, but it's basically like a super solid kind of. It's very very cold. So when you make something that is a liquid colder, it turns into a solid, right? Like water, right? Take water, make it colder, it turns into ice. If you keep going though, keep making it very 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 cold, it breaks down at like the atomic level, which is why I don't consider the other two really like true states of matter, because an Einstein-Rosen condensate, without getting too far on a rabbit trail here, it doesn't have the same structure. It doesn't have like your typical protons, neutrons, electrons, electrons spinning around the nucleus of protons and neutrons and that kind of thing. So it doesn't have that same atomic structure. Same thing with plasma. So plasma is sort of like the opposite of Einstein-Rosen condensate. Plasma would be like, if you take gas and then you keep heating it up, sort of like the sun. Like the sun has plasma. So then it's the same thing. So the structure of each atom is broken down. It's not really the get my Windows device summary over here. So it's not the same as. I'm trying to get my mouse to go away. Come on. All right, let's do that. Maybe that'll work. Sorry. Squirrel. Can't get my mouse to go away. All right, hold on. I will get this to go away eventually. There we go. Okay. So with plasma, you have the atomic structure is broken down again. So basically, three states of matter: solid, liquid, and gas. So three again, right? What about the parts? What about the parts? So what about like what is what are the parts of an atom? Well, there's a lot of different little parts like quarks and stuff, right? But like again, in school, basic three parts of building an atom. You have your protons, you have your neutrons, and you have your electrons. If you change the amount of protons, then you have a different element. If you change the amount of electrons, then you have different ions of that element. Let me know again if in the comments if I'm off a little bit here. My science is not as good as my math. And then if you change the amount of neutrons, you have isotopes. So the protons are what determines the what element it is. But there's three things, right? So protons, electrons, neutrons. There's three of those, right? And then just so many other things, right? So those are some of the more fundamental things. But what about colors, right? Like blue, yellow, and red, the three primary colors, or the three secondary colors, purple, green, orange. What about black, white, and gray, right? So that's kind of more of a spectrum. But a lot of these other things are a spectrum. So basically everything else that I can think of is a spectrum of things. So like when you think of you have one extreme or the other extreme, and then you have something in the middle. That's how a spectrum is normally structured, right? Like you either think of a spectrum as the furthest extreme one way, or the furthest extreme the other way, or everything in the middle is all like clumped together as one thing, or you have the middle is exactly one thing, and then anything to the right of the middle is one extreme, and anything to the left of the middle is the other extreme. So there's kind of a couple different ways to think about that. So one example would be time, right? Like so time is three things. It's past, present, and future. It's a spectrum. In the middle, you have present, right, like right now, but it's small. It's not. It's infinitesimal. It's right in the middle between past and present, and everything that's before present is past, and everything that's after present is future. So still three things though, and it's a spectrum. But pretty much every spectrum, you have three categories. You have the far left, the far right, and what's in the middle, right? So time is a spectrum, but it's also three. It's also a three again, or sometimes I call it a trichotomy. So if you've ever heard of a dichotomy is like when you have to choose between two things, like yes or no, right? If you say, do you want leftovers, right? Yes or no, right? It's a dichotomy. You say yes or you say no. Um, but I tend to think more in trichotomies than dichotomies. I don't like dichotomies. I think trichotomies make more sense, and it seems to make more sense too because of the way it seems like the universe works. The universe just seems to work with this number three in mind. It's just some sort of cosmic number, right? And so with any other kind of spectrum, you're gonna have what's in the middle. So like white, black, and gray, right? So that's like the opposite of time. Time has a really infinitesimally small middle, and then anything to the left is past, anything to the right is future. Whereas with black, white, and gray, it's the opposite kind. Black is like all the way the darkest, 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 and then white is the whitest, whitest, whitest. Like if you go to the paint store and they're like, oh, do you want an off-white? Well, that's not white. They have to call it something else. They call it like eggshell white or off-white. I always just thought it was white because I'm not that great with colors. Like it just looks white. Off-whites just look white to me. But apparently, if it's not the whitest white, then it's not white. So everything else is gray. Everything in the middle, if you're not, doing any kind of colors, right? Like grayscale, if you've ever heard of grayscale. Like the absolute white and the absolute black, and then anything in the middle is a shade of gray. So that's the opposite. So you still have three parts. You still have a spectrum, and you still have three parts. It's just that the outside most parts are both considered like particular things, and then everything in the middle is what's left over, basically. So a large middle. And that's kind of how pretty much every spectrum works. You've got three parts, and that's it. And then the other thing too, here's another thing about spectrums of things, and how they all are trichotomies. You have different kinds of spectrums as well. So time, for instance, time could be an infinite spectrum. Maybe if the universe is infinitely old, like if some sort of Big Bang theory, if you have a pre-Big Bang theory where like you have a continuous like the universe has a Big Bang and then it expands and then it eventually comes back together, collapses onto itself again into an infinitesimal dot, like people think, and then it has another Big Bang, and it just keeps doing that. There's a cycle like that. Some people think there's a cycle. If that's true, then time would truly be infinite in both directions. So it would be an infinite spectrum. I don't think that's true. I think time had a finite beginning. I think that's the most plausible thing. I think most scientists, most credible scientists, are are in that camp that time had a finite beginning. So that would be what's called a hybrid spectrum, because as far as we know, time won't ever end as long as there's matter. And I don't think the matter is going to collapse on itself. I think it's going to just continue to expand. Then there's time. There will be time. If nobody's around to measure time, time's still going to happen. So, even after people go away, on the earth. But I believe time would be a hybrid spectrum. It has a finite beginning and then an infinite end. There's still three parts. There's still the beginning, the middle, and the end. It's just that the beginning is finite and the end is infinite. It's a finite, infinite end. Then you would have, so that's a hybrid spectrum, as opposed to an infinite spectrum. Like if time is actually infinite in the past, then that would be an infinite spectrum. Then you have a finite spectrum, which would be like the color spectrum. So the visible color spectrum is finite. It has a certain beginning and a certain end. I think it starts with, I want to say it starts with purple and ends with red. Yeah. Let me know if I'm off a little bit there, or maybe it starts with red and ends with purple, depending on how you think about it. But it's on one end you have purple, and on the other end you have red, and then everything in between that you can think of, right? Like different all the different primary and secondary colors that I didn't say, apart from red and purple, and then all the other tertiary colors too, like teal, like a blue green, and all the other colors. The whole rainbow, and that's why rainbows work the way they do. Actually, is because it's the whole visible light spectrum. But when you look at that spectrum, the visible light spectrum, that's a finite spectrum because it has a clear a beginning and a clear end. It doesn't keep going in either direction, and it has a middle as well. And then that one, so that would be your finite spectrum. So pretty much everything you can think of, and I challenge you to do this. I challenge you to think of some sort of fundamental thing, not something trivial like types of wood or something. Like I'm sure there's like hundreds of different types of wood, or I don't know, like different kinds of calculators or something, right? Like that's man-made stuff, like just fundamental things. I challenge you to think of one fundamental thing that's not actually a trichotomy. Because I've thought about this a lot, and I can't think of anything that you couldn't put into three categories. There just doesn't seem to really be anything that does not fit into three categories. There's three. There's just three all the time. There's hot, cold, and lukewarm. There's good, bad, and you're just average or whatever. But yeah, so there doesn't seem to be any. So I challenge you to let me know in the comments if you can think of something that is not really three camps or three categories, a trichotomy of things, and let me know in the comments. But yeah, so thanks for listening to my random ramblings today. I was thinking about putting this on creating a different channel where I just spat out random ramblings, but this had to do with math. It was the number 3, so I thought I would put this on this channel instead. If you have been following some of my videos, normally I don't do stuff like this, but normally my videos involve math content stuff, either teaching it, so where I'm teaching to you as a student, if you're watching this as a student, or I'm also gonna start incorporating more content for other people coming on here. So content for parents or teachers, teaching homeschool or teaching classroom. I spent a little bit of time in the classroom as well. So I'll be probably putting out resources for that, but specifically probably for tutors and homeschool parents, because homeschool parents and tutors are kind of roughly the same thing ish. So I'll be putting out content for that too. So if that kind of stuff sounds interesting, go check out some of those other videos on YouTube. And also go check out some resources that I have on my website, myersmathematics.com. I'll be putting some more stuff on there periodically throughout the, days, years, etc., etc. So go check that out, myersmathematics.com. I've got a free piece of content at the beginning of the website. You just go to the main page, and it's called the 5 Math Mistakes Everyone Makes and How to Avoid Them. You can download that free guide just by going to that main page. But you can look around there and see what else is on there. I'm going to have all kinds of different stuff on there. I want to try to have it be an avenue where you can just get all the different content that you might need, whether you're looking at content as a learner or as a teacher or something in between maybe. So yeah, so I'm going to be doing that, and so go check that out. And of course, like any other person who puts things on YouTube, if you want to go ahead and do that like and that comment and subscribe and all the things, then go ahead and do that too. If you've made it till the end, then you thought it was worth watching till now. So go ahead and let me know what you think. Tell me if you can think of anything that's not a trichotomy, or just list a trichotomy that I didn't mention. That's like a fundamental thing in the universe, and let me know about that in the comments below. And I will see you in another episode real soon.